So just like I said in the second video, if you'd like more detail on how to draw the graphs of these transformations of the log base 2 of x parent function, then please watch the first video. I have lots more detail in that video. I even have colors in that video too. You might like that. So anyway, we always start with our parent function that has a key point here at 1, 0. And then it goes up like this and comes over like that. But here we see we have a negative x, log base 2 of negative x. So we're going to reflect this graph about the y-axis, just like we did in that first video. So we reflected about the y-axis, but then that minus 4 tells us we're going to go down 4 units. So if we go down 4 units, currently the key point after reflecting it about the y-axis is at negative 1, 0. And moving this point down 1, 2, 3, 4, the coordinates of that point now are negative 1, negative 4. Don't forget, after drawing the key point, it's nice and helpful to draw the asymptote. Since the y-axis acts as the asymptote, you don't actually have to draw it, but I like to draw it for effect so you can make sure you know, I know you know where that vertical asymptote is. And then you come up here like this, and then you just start curving over. And as you've seen in previous videos in class, nothing fancy here. Just make sure you know where the key point is and where the vertical asymptote is. And then you can start answering questions about domain, range, and all those things. So the domain, you can see, you can either write it as negative infinity to 0, or you can write it as all x values such that x is less than 0. Again, range is always all real numbers for the logs, and the domain and range flip-flop when you have exponential logs, so we talked about that. We see that the y values are actually getting smaller from negative infinity all the way to 0. So as you move to the right, from left to right, from negative infinity to 0, the y values are getting smaller. No horizontal asymptotes, but as we've talked about, the vertical asymptote is x equals 0. And then let's go ahead and find our x-intercept. We can see it's a big negative number, and let's do that to the left here. So to find, you always want to make sure you show the work for this. Anytime we're finding an x-intercept, we're going to go ahead and allow y to be equal to 0. And then again, we have log base 2 of negative x and then minus 4. So if we add 4 to both sides, we get 4 is equal to the log base 2 of the opposite of x, or negative x, however you want to say it. And then notice our variable is locked up in the argument. Once that happens and we have the log on one side and no numbers on the other, we're going to convert this to exponential form. So this needs to be something that you can just do. Exponential form, you take the base, raise it to the exponent, and remember the exponent is the log, so 4 is the exponent, and then that's equal to the argument. Multiplying both sides by, let's do this first. So 2 to the 4th is 16. Multiplying both sides by negative 1, or dividing by negative 1, we see that x is equal to negative 16. So that's our x-intercept, negative 16 comma 0. We can see also that this graph does not cross the y-axis. And then we have no max, no min. 1 to 1 here. Yes is 1 to 1, and then we've done this for the rest of these guys. So NA and then none. That's it.